Hi friends, welcome to CAT Engineers Academy online platform. So in today's class, we will discuss how to solve the problems, how to analyze the electrical circuits by using nodal analysis. So in today's class, just we have to consider one problem and then we have to see how to solve the problem by using nodal analysis. Okay friends, please listen carefully and watch the video step by step until completion of the problem. Then only you will get the clear idea how to solve the problem. Okay friends, then we will go for the problem. Okay, just listen. So here I consider the problem. Just example problem here I consider. So this is the problem. Just here problem they are asking that find the current flowing through the 2 ohms and 6 ohms resistor by using nodal analysis. So simply they are asking the current through 2 ohms resistor, 6 ohms resistor by using nodal analysis, whatever the problem they are given. So in that problem, just to see wherever we are having 2 ohms and 6 ohms. So here we are having 2 ohms, next here we are having 6 ohms. Now they are asking final question, what is the current flowing through the 2 ohms as well as the 6 ohms due to this 5 amps current source as well as due to this 10 amps current source. Okay, they are giving two current sources as well as three elements are connected as like this. Though they are connected, the elements are in this circuit. In this circuit we have to find out the current in 2 ohms, 6 ohms by using nodal analysis. Okay friends, already I explained the last video how to solve the problem by using nodal analysis. I explained the concept. So by using that concept, here I am solving the problem. If you don't have any concept, first you have to watch that video, then you will get that. Otherwise directly you can see this problem, you can understand directly also. Okay, so first you have to go for the solution. So just listen. Whenever we are solving the problem by using nodal analysis, we are having 4 steps. Just you have to follow the 4 steps, then finally we will get the answer. So first you are considering the step 1. So what is the step 1? So step 1 is, first you have to identify the number of nodes in a given circuit. So first identify total number of nodes. Total number of nodes. First identify the total number of nodes. Okay. Now first step is identify the total. But whatever the nodes here is nothing but principal nodes only. Don't consider the simple nodes. Principal nodes is nothing but where the current division takes place. Otherwise, 3 elements are interconnected with that you are considered as a node. Now finally just here 5 amps, 2 ohms, 4 ohms is connected at this point. Now finally you can consider this one as one node. Here I consider this one as 1. Next see this 5 amps here, 4 amps and 6 ohms are connected here. 4 ohms, 6 ohms, 5 amps are connected to this node as well as this 10 amps also connected here. 4 elements are connected here is nothing but this one you got to consider as a one node. Okay, so finally this is second node. Second node. Now the below bottom you have to see 2 ohms, 6 ohms, 10 ohms. So all are connected here. At any one point you have to consider as a one node. Now finally I consider this one as one node. Now this node I consider as a reference node. Okay, because one node you have to consider as a reference node. Ground point you have to consider as a reference node. Now here I have considered this one as a ground. Next you have to give this one as reference node number as 0. So finally here you have to consider this one as reference node. You have to consider reference node. So finally total number of nodes are 0, 1, 2. So total number of nodes are 3. So in that 2 are non-reference node. It is very important. You have to mention non-reference nodes as well as reference node. So 1 reference node, 1 reference node. 2 are the non-reference nodes, 1 is reference node. So it is first step. Just everyone follow this. First step is identify the number of nodes. So finally here we are having 3 number of nodes. Next step 3. Sorry, step 2. Assign voltage variables. Assign voltage variables at non-reference nodes. At non-reference nodes. So finally, assign voltage variables at non-reference nodes. So now how many non-reference nodes we are having? Two non-reference nodes. So two non-reference nodes at first node, at that node you have to consider some assign the voltage variables. Here I am assuming the voltage variable is V1 suffix 1. Next here at the second node, here I am assuming the voltage is assign the voltage variable is V2. Only for non-reference node. So finally that is V1 and V2. V1 and V2. So this is the second step. Okay. Next, assign the voltage variables nothing but by using nodal analysis. First, we have to calculate the voltage at the nodes. Then only we will get the current in 2 ohms as well as the 6 ohms. Because current in this 2 ohms nothing but we have to know the what is the voltage across this 2 ohms. Then only we can calculate the, because nodal analysis is nothing but KCL plus Ohm's law. Finally, we get the response. Okay. Step 3 is nothing but next write KCL, write KCL equation, write KCL equations at non-reference nodes, write KCL equation at non-reference nodes. Okay friends, whenever you are writing the KCL equation at non-reference node, you have to remember one is important point. Here we have to follow some step. That first step is, here also we are having some part, that is before writing the KCL at first node or second node any given equation, first you have to assign the current directions. So first you have to remember before you are writing the KCL equation, first assign current directions, assign current directions to all, sorry, not all nodes, to all branches, So first here at nodes we have to assign the current directions. So just listen friends, if they are given any current directions, you have to consider that current directions. Otherwise you can follow all our outgoing current directions. So here I am having this one is, I consider the outgoing current direction is small I1. Next here I consider this one as, I consider as a I2, because at first node 3 elements are interconnected. Okay. Now here they are given this one as input current direction. So you can consider as a output or input. So better you can consider all our output. It is very easy to understand. So finally here I consider all directions are outgoing direction. Even though they are given current also, you can consider outgoing, no problem. So here I given I1, I2, I3. So before here I am writing the case equation first node, for example, you have to give the current directions at first node branches. Next, whenever you are writing the case equation at second branch, here also you have to give the current directions. So here also I am giving the current directions. Okay, just listen. So here I consider this one as I4. Now this one is considered as I5. So I4, I5. Next, remaining two branches. So already we are having I3 and I2. I3 in this direction and I2 in this direction. You can consider any new variable. Otherwise, you can consider the same variable also. No problem. Definitely you will get the answer. For example, you consider new variables. No problem. For example, here I consider this one as I6. Next, this one I consider as a I7. You can consider any direction, no problem. Already if you are having I3, that I3 is nothing but opposite to I6 you will get. Okay. Now finally write KCL equation at node 1. KCL equation at node 1. So finally here I am writing the KCL equation at node 1. So how many currents are here? According to the KCL, the sum of the currents away from the node is 0. So I1 plus I2 plus I3 equal to 0. I1 plus I2 plus I3 equal to 0. So finally I1 plus I2 plus I3 equal to 0. So I1 plus I2 plus I3 equal to 0. Now finally what is I1? I1 is nothing but current flowing through the 2 ohms, that you are writing in terms of voltage as well as resistors. Already I told that in last class only how to write the equation. So finally I consider this one as that is potential difference between these two elements. Potential difference between this element is V1 minus 0 by 2. So first one is I1 is V1 minus 0 by 2. Next plus I2. I2 is current flowing through the 4 ohms. That is potential difference V1 minus this node V2. So V1 minus V2 by 4. So V1 minus V2 by 4 plus I3. So I3 current already they are given, the I3 value is, that is 5 amps. So 5 amps is opposite to I3 is nothing but you can consider this value as negative value, that is minus 5. So finally this is equal to 0. Now by simplifying this equation we will get the answer, that LCM. So finally we will get the 2V1 minus 0 plus V1 minus V2, next minus 20 equal to 0. So finally here we will get the answer as 3V1 minus V2 equal to 20. Now you have to consider this equation as first equation. Then write the KCL at second equation. So step 3 is write the KCL equation. So write KCL equation at node 2. KCL equation at node 2. So write the KCL equation at node 2. The what is that KCL equation at node 2 is, see here, what are the currents are going here? I4, I5, I6, and one more current we have to give the direction in this 6 ohms. Okay, 6 ohms already given. I4, I5, I6, I7. So finally here we can write I4 plus I5 plus I6 plus I7 equal to 0. So like that you first you have to write the equation. Next you write current equations in terms of voltages. So first I4. So I4 is current flowing through the 6 ohms. So that is V2 minus 0 by 6. Next, whenever you are writing the I7 is V2 minus V1 by 4. Next, whenever you are writing I5, it is opposite to the 10. So minus 10. Next, I6 is V2 minus V1 by, sorry, already they are given the current directions. So I6 equal to 5. Okay. Now I4 and I7. So I4 is V2 minus 0 by 6 plus, so I5 they are asking where we are assigning I5. Okay, I5 is opposite to 10 ohms, so minus 10. I6 is in the same direction is 5, so plus 5. Okay, so minus 10 plus 5 plus I7 is V2 minus V1 by 4 equal to 0. Now simplify this equation. So 6 and 4 LCM is the 12. So finally we get the answer is 6 2. So 2V2 plus, sorry, minus, so 2 6 12 minus 120. Next plus 12 5 is 60 plus 4 3 3V2 minus 3V1 equal to 0. Now by taking the LCM, 6 and 4 will be the 12. By simplifying we will get the equation like this. So 3V2 5V2, so minus 3V1 plus 5V2 plus 5V2, next minus 120 plus 60, so equal to will get the 60. So final equation is minus 3V1 plus 5V2 equal to 60. Now finally you can consider this equation as second equation. So finally step 3 is over. So step 3 we are writing the KCL equation at non-reference node, that is at first node and second node. Next you go for the last step. Step 4 is nothing but modify the, that is rearrange the, otherwise solve the KCL equations to obtain the solve KCL equations to obtain node voltage. To obtain node voltages. To obtain node voltages. So first KCL equation. So how we have to solve the KCL equations? By considering the two equations, you have to simplify by using any method. So that is as your wish, normal method. Otherwise, by can use it by using the calc also you can calculate the answer. So finally, first equation is 3v1 minus v2 equal to 20. Next second equation is minus 3v1 plus 5v2 equal to 60. Now by solving these two equations, already I know this is first equation, this is second equation. Now for that here I am writing the answer by solving first and second equations. So by using calculus we can solve the problems. So by solving the KCL equations we will get the V1 as 13.33 volts. Next V2 is 20 volts. V2 is 20 volts. Okay friends. So finally like that you have to solve the problem. So finally we are obtaining the node voltage. So by using this node voltage you have to calculate the currents in 2 ohms resistor and 6 ohm resistor. So next our intention is calculate the current. So first the current in 2 ohms resistor, first you have to calculate the current in 2 ohms resistor. Current in 2 ohms resistor. Current in 2 ohms resistor. So that current in 2 ohm resistor is, what is our current in 2 ohms resistor? 2 ohms resistor. See I1. So current in 2 ohms resistor is I1. What is that I1? Is nothing but V1 minus 0 by 2. Already V1 calculated, that you have to substitute. Okay. Next they are asking current is 6 ohms also. 6 ohms is nothing but that is I4. I4 is nothing but V2 minus 0 by 6. Okay. So first you have to calculate the I1. Next you go for the I4. So current in 2 ohms resistor is I1. That is V1 minus 0 by 2. That is potential difference between that element by resistor. So V1 is already we are calculated 30.33 minus 0 by 2. So this answer is 6.666 amps. Okay, I1 is over. Next to go for the I2. So not I2, I4. That is the current in 6 ohms resistor. Current in 6 ohm resistor. So I4 equal to V2 minus 0 by 6. So V2 is how much we calculated, that is V2 is 20 volts. So 20 minus 0 by 6. So finally we can obtain this answer is 3.33 amps. Okay. So finally we obtain I1 and I2. Okay friends. So by using this procedure we have to solve the problems by using nodal analysis. Okay friends. If you like the video, share the video to your friends and give the likes and subscribe the channel for more videos. Thank you one and all. We will meet in the next class.